action.
So for this problem, you're going to be looking for the future value of the investment's cash flows at the end of 5 years. So for the future value equation, it's going to be future value equals PV. PV is going to be, it's going to be lump sum. And then this is 1 plus I to the power of n. And then the regular equation for the solution is going to be 6.2 is future value to the fifth, which is going to be finding at the end of 5 years. And then you input the so that's going to be 2,350, which is going to be from the end of year 1. So this whole block is going to be end of year 1. There's going to be year 2, year 3, year 4, and then after that you hit your year 5, which is going to give you 17,498.75, and that'll be the future value at the end of 5 years. And then on to 6.3, we're also using the same equation for future value. And it's going to be the same instance where you're going to be having each year in a bracket. So this problem we're going to be looking for a future value of ended in 4 years. So year 1, year 2, and then year 3. And then at the end of year 4, you're going to get your answer, which is going to be 74,472 at the end of 4 years.
Come on, just one clap.
Okay, so I did 6.16. Basically, guy bought a car and put a down payment, and they want to find the effective annual interest rate if the loan payments are made monthly. So the loan amount, which is PV, is $11,345. The interest rate on the loan is 4.9%. The frequency of compounding, which is N, is 12 because 12 obviously for once a year. And then EAR stands for the effective annual rate. So the equation is EAR equals 1 plus I over n to the n times 1 minus 1. So then you put in the 4.9% for I and the 12 for 12 months for n. Put it to n power times 1, subtract 1, and you get 5%. So the EAR if the loan payments are made monthly is 5%. For 6.17, basically a similar situation. The interest rate on the loan is 6.75%. Loan amount is $15,550. The frequency of compounding M is 365, as it is compounding daily. So, and then the EAR again is what we're calculating. Use the same equation, plug in each of the variables into the equation, and you come out with 6.98% for the EAR as it is compounding daily. You inherited $550,000 and you get 4.6% interest annually. You're trying to see how many years it will take for you to get $1 million. So use this formula with future value, and you just put in all your equations and you're trying to find n, and then you get it out to 13.29 years. Okay, for 6.7, for the investment opportunity requires a payment of $750 for 12 years, starting from year today. If you want to find what the value is of investment created today, based off of your return rate of 8%. So basically your annual payment for your PMT is going to be $750. Your number of payments is 12.
which is N, and then required rate of return is 8%, and then your present value of investments, or your PVA, is 12, and then you plug it into the formula PVAN equals PMT times 1 minus 1 over 1 plus I think it's N, and then all over I. You plug it all in, and you should get 5,652.06.
So I did 5.27 and 5.29. And for 5.27, it's telling us that this company made this much of sales in 2017, and they're expecting that the sales will go up to 47,450 in 3 years. And then the question is asking us at which rate are the company's sales expected to grow. So this is the formula that we're going to use, and then we're going to do 47,450 divided by, so that we're going to do the future expected growth divided by the present growth, and then we're going to get the rate, and then multiply that by 1/3 minus 1, and then we get 10.42, which is the expected growth rate. And then for 5.29, the question is asking if Caroline should accept the bonus of 1,820 today, or wait 2 years and accept 2,100. So, this is the formula. It's the present value equals future value divided by 1 plus interest to the power of n. And then what we're going to do is we're going to take the future value, which is 2,100, divide that by the interest rate, which is 6% plus 1, so 1.6, and then multiplied by n, which is the duration, and that's 2 years. And then we're going to get 1,868, which is higher than 1,820, so she should wait 2 years because she'll get it. So I did 5.33. So for this problem, you have $12,000 in cash, and you're looking to either invest it in your brother's business or to deposit it in a mutual fund. So, so this is how much you have, and you're also going to invest exactly the amount for a period of 10 years. So you'll get 8.2% interest back if you invest in your brother's business, and then the frequency of compounding is 2, and then the value of investment after 10 years is what's deposited in here. So this bottom formula, which is the your amount that you're investing, and then 1 plus the percentage you get back for the interest, and then over the frequency of compounding, which is 2. And then ultimately you find out that you get about $27,000 back if you invest in your brother's business, 8.2% interest rate.
Alright, 7.2, playing Let's Make a Deal. You got 2 curtains, one of them has $150, one of them has $7,200. $7,200, you have a 25% chance to get the $7,200 curtain, and a 75% chance to get the $150. The question is, what's the expected value of the selection, and what's the standard deviation of the selection? So set up for the first one, the expected value is going to be the percent chance of getting that curtain times the price of that prize. So 75% times 150 plus 25% plus times 7,200 is $1,912.50. For the standard deviation, you're just taking the percent likelihood of getting that selection times the price of that selection minus the expected value. So 75% times 150 minus 1912.50 squared plus 25% times 7,200 minus 1912.50 squared. And we just square root both sides. 9,019,218.75 comes
same thing with the next problem. The next problem was asking, you have a 10% chance of getting to medical school and then graduate with a $300,000 per year salary, or you just go straight into the zoo business and make $40,000 a year. The same setup, 90% chance to make 40 grand per year plus 10% chance to make 30 grand per year, $66,000. Same thing for the next one. 90% times 40,000 minus 66,000 squared plus 10% times 300,000 6,000 squared. That comes out to $78,000.
For 7.27, it's asking for the expected return on Twitter stocks. So to get this, you just have to add the risk-free rate plus the beta on Twitter stocks, and then you multiply that by the risk premium. The value you get is 8.91. For the next question, it's asking for the beta. And to get this, all we have to do is subtract the risk-free rate by the expected return on bonds, and you multiply that by the market risk premium, which you get. You get 0.35.
Yeah, bro.
Item 515, and you're just looking for the interest rate on investment. And so it gives you the amount you're gonna borrow and then the amount that you have to pay back at the end of 2 years. And so then the formula is the present value equals the future value in 2 years divided by the 1 plus the investment to the power of 2 years. And when you plug it in and you do it all, you realize that the interest rate is 7.42%, which is more than you would if you borrowed from the bank. So they recommend you borrow from the bank instead.
Okay, so I had 6.1, which is Croncat Inc., and they're expecting cash inflows of 13,000, 11,500, 12,750, and 9,635 over the next 4 years. What is the present value of these cash flows if the appropriate discount rate is 3%? So basically, you're going to add up all the present values and divide by the 1.08, like the 8%. And then once you get that, and then as you go on in the years, the end value is the number of years, and that's the power of the percentage. So then you get these numbers all here, and you add them all up for a total of $39,099.80. And then for 5.5, it was the 5.5 was asking about some active patients, and they're asking what the compound annual growth rate will be, or what the compound annual growth rate is from 2013 to 2017. In 2013, they had 42,725 patients, and in 2017, they had 47,663 patients. So in order to find that, you do the equation, the present value equals the final value of n number of years over 1 plus the growth rate, which is denoted as I to the nth power for the number of years. So if you were to do this, so then what you do is bring the 1 plus I to the 4th power over, and then divide the 47,000 by the 42,000, which gives you 1.1156. And then you have to put that, since it's to the 4th power, you put it to the 1/4 power, and then that'll give you, and minus 1, like do the opposite on both sides, and then that gives you 2.77% of a compound annual growth rate.
So I did compounding interest with monthly payments. So a person has $10,000 in the bank and they're able to put in $100 every month. Additionally, after that, when they're trying to get to $25,000, if it's plug it all into this formula, which is the future value equals the monthly payments, or the payments we put in, times 1 plus the interest over the compounding payments, times the amount, the power of the amount of months, minus 1 over the interest over the compounding, plus the present value times the same thing. And after plugging it all in, you have to use natural logs to pull out the exponent, and then define the amount of months, which is 31.3 months.
So my question is about a coin flip, and it's, the first part is the winner, or whoever wins, or whoever loses has to pay the other person $15. So we're trying to figure out the expected cash flow for that. You just put it into the equation, you multiply it by the probability of winning, which is 50%. And so the expected cash flow on that is 0. And then to find the variance of that cash flow, we put the expected cash flow into this equation. And that ends up being 225 as the variance cash flow. And then the second part of the question is if one of the people in the bet ends up paying $20 instead of $15. So we put it into the same equation for the expected cash flow. That ends up being $2.50. And then we put that into the variance cash flow equation, and we end up getting $306.25.
So my problem involved calculating the variance instead of deviation. So to calculate, first we calculate the expected returns, which is multiplying each probability by each return. We get 0.125, and then we want to calculate the variance. So it's going to be the return minus the expected return squared times the probability, in which we get 0.02809, and then we want the standard deviation, which is the square root of that, and we get 0.168.
I did 6.5, so Dynamo Corporation is expecting an annual payment of $34,225 for the next 7 years. And basically, the question wants you to find out the present value of this annuity if the discount rate is 8.5%. So I started by drawing out a timeline for the cash flow. So as you can see, 34,225, and then that's the 8.5% discount rate. So then to find the answer, you pretty much use the present value formula, which is the cash flow times 1 minus 1 divided by 1 plus I, and I is the discount rate, and then N is the time period, and then divided by the discount rate, which is 8.5%, so 0.085. So you do 34,225 times 1 minus 1 divided by 1.05 to the 7th power over 0.85, and that gives you $175,181.14, or $1.14.
Alright, 5.24 was if you deposited $850 into a savings account, CD, and you're going to withdraw the money only once when the balance reaches $1,000. How long will it take if the bank pays 5% interest to get to $1,000? So given we have amount invested today is $850, future value is $1,000, interest rate is 5%. Formula in finding this is future value equals present value of 1 plus the interest rate to the nth power, which is time, which is what we're trying to find. Plug in the numbers that we know to find n. 1,000 equals 150 times 1.05. And then 1.05 to the n equals 1,000 over 850 equals, which this fraction equals 1.1764. And then you would take the ln of 1.05 of both sides, making n to equal ln of 1.1764 over the ln of 1.05 equal to 3.3 years.
Okay, so 5.30, it's basically a part 2 of 5.29, which is over there. That's where we get the numbers. And it's basically just looking at if this woman should take her bonus today or in 2 years because of a new federal tax rate. And so if she takes it today, it'll take 35%. And if she takes it in 2 years, it'll take 40%. So you just plug it into this equation and you get 1183. And then if you plug it in for the 2 years, you would get $1,121.40. And so the answer is yes, the corporate tax rate would affect her decision because she would get a different monetary amount. And then for 5.31, it's about investing in a classmate startup business. And so you're trying to find the rate of return. So what you would do to find that is use the future value equation, and you would just set up all the givens, and you would get 13.96%.
So this is 6.5, which is calculating the effective annual rate. So if you have a credit card offers financing an APR of 18% with monthly compounding on outstanding charges. So what is the effective annual rate? Interest rate is 18%, compounds monthly, so 12 times a year. The effective annual rate would be 1 plus the interest rate over the times compounded, the power of the times compounded minus 1. So you plug it in, you get 1.1956 minus 1, which is about 0.1956 or 19.56%.
So I did 5.36. So for this one, we're looking at a company who their sales are predicted to grow at a rate of 7% per year, and basically they want to buy like a new fleet of trucks to help in their distribution. So they're trying to determine at what point they'll be able to buy these trucks, and so they want to do that once their net income reaches $620,000 a year. So we're trying to figure out how long that will take. So let's see. So we have all of these values that are given as the profit margin, the net income, which we know grows at 7% per year. Let's see. And then we have to calculate the future value. So we do this formula here. And we have to take the log of these numbers. And then ultimately we get 3.7 years in order for them to buy their trucks.
Alright, so 5.12 present value. So Tracy Chapman is trying to buy a house and she plans to put 20% down at that time. She needs $35,000. So if Tracy can invest in a fund that pays 9.25% annual interest compounded quarterly, how much will she have to invest today? So you take the return expected from investment, which is the 9.25 divided by 4 since it's compounded quarterly. The duration of the investment is 5 times 4 because it's over 5 years quarterly. And then the amount to be invested today would be the present value. This is the equation right here, future value over 1 plus the return expected from investment. So that's 35,000 divided by 1.0231 to the power of 4 times 5, which gives you roughly $22,000.
Alright, so I did 6.21, and for this problem, it's pretty much someone just won the lottery and is going to receive payments over the next 7 years, and someone wants to buy them or pay them a lump sum to like buy the whole amount of cash flows. So you have an expected rate of return of 10.5%, an investment period of I like I said earlier, over 7 years. And so you're trying to find the future value in 7 years.
Okay.
So what you do is you take like the first year of 200,000, you divide it by 1.105, then you add this, and then you do the same thing for the next year, and then you do this 7 times because there's 7 years. And so after you do all this math,
Okay.
I'm not going to say all these numbers, but you can see is all these right here, and you get a total of $1,496,377, or $1,496,377.71, and that's what the investor is going to have to pay her in order for Carol to make her money back.
Alright, so I did 6.31, and the question asks, which of the following investments has the highest effective annual interest rate? And it gives you 5 options: 8.25% compounded quarterly, 8.25% compounded monthly, 8.45% compounded annually, 8.25% compounded semi-annually, and 8% daily. And the answer is going to be B, which would be 8.25% monthly. And the way you do that is, so basically you state out your variables. The interest rate, 8.25%, it's compounded 12 times because there's 12 months. And so then you get your equation, EAR equals bracket 1 plus I over m minus 1, and then it's to the power of m times 1, m being the number of months. So it would be 1 plus the percentage, 0.0825 divided by 1 to the power of 12 minus 1, and then you get 1.0857 minus 1, which would be 8.57%, which would be the highest. But the way to actually solve the problem is you'd have to go through and solve one by one and find the percentage of each one, but that would take up the whole board. So, answer is B.
I did 5.8 and 5.9. So for 5.8, it says there's a catcher for the Minnesota Twins. He was expected to hit 15 home runs in 2018. If his home run hitting ability is expected to grow by 12% every year for the following 5 years, how many home runs is he expected to hit in 2023? So you do the present value, which is 15, and you're looking for the future value. So to do that, you do the present value times 1 plus your rate, which is 12%, to the 5 years. And once you do that, you get 26.4, and you round that to 26 as a whole number, because you can hit 26 home runs. And then for 5.9, it says Rory Gross is considering an investment that pays 7.6% compounded annually. How much will he have to invest today so that the investment will be worth $25,000 in 6 years? So you do $25,000, which is the total, over 1 plus the rate, which is 7.6%, to the 6, because it's 6 years, and then you get $16,108.92.
So I had 519 and 520. So for 519, it's a future value problem. And you're trying to found an online dating app. And you know that you have 450 people who will sign up immediately. So they're giving you a present value of 450 people. And they're also telling you that your membership will grow by 27% in the first 2 years, 22% in the 3rd year, and 18% in the 4th year. So pretty much you're just going to take all of these numbers, and you're solving for the future value after the 4th year. So you're taking the present value, plugging it in, and then multiplying it by these 3 numbers, and your total should come out to about 1,045 numbers. And then for 520, it's multiple compounding period problems. So pretty much they're just giving you a bunch of different scenarios, and you're just going to go through them all and kind of just plug and go. So you have a future value of an investment, or you're trying to find the future value of an investment of $2,500, and the first scenario A is a 6.25% compounded semi-annually for about 12 years. And yeah, you're just going to plug and go, and then you're going to get an answer around $5,000. And yeah, the rest is pretty self-explanatory. I'm just going to
plug and go based off of the different scenarios it asks you.